Good afternoon, everyone, and thank you for joining me today. I am Wajdi Sahawneh. I am the Operations Director in Colabri. I'm a civil engineer with a master's degree in construction management from the University of Salford, Manchester. I'm a professional engineer in engineering management, associate member of the Royal Institute of Chartered Surveyors, PMP certified and Autodesk certified professional in Autodesk Revit. We are Colabri. Colabri is a UK-based company. We are BIM consultants with operations bases in the UK, Saudi Arabia, Jordan, and United Arab Emirates. Today we're going to talk about data. How we can utilize the amount of data sitting in our softwares or servers or cloud platforms without being utilized properly to boost our efficiency and to enhance our day-to-day activities, to get better quality, more accuracy of our BIM models. But first, let's step back for a moment to refresh our memories of the definition of BIM according to the ISO. The BIM definition according to ISO 19650-1, which is the concepts and principles chapter of that series, describes BIM as the use of a shared digital representation of a built asset to facilitate design, construction, and operation processes to form a reliable basis for decisions, which means if we want to have informed decisions, we need to have the highest accuracy in terms of information. We need the information in the right form and in timely manner. In Colabri, we came up with a term called the BIM pyramid. It's layering the requirements and the bits that you need to be able to be BIM enabled and to work in a BIM environment. The first stone of that pyramid is the specifications and standards. And by default, we're talking about the ISO 19650. We have to understand it. We have to apply it. We have to achieve its requirements in order to be BIM enabled. That is the first step we need. Once we understand the ISO 19650 and we apply it in our workplaces and our processes, we come up to the documentation which is based on the ISO 19650, which tells us what that document needs to have. For example, the exchange information requirements. It dictates what process we need to follow in terms of BIM implementation in the delivery phase. Once we have our requirements, once we define our objectives in the exchange information requirements, we come to the procedures, which is identified in the BIM execution plan. The BIM execution plans, it's a document that we all know. We have been seeing a lot of forms and templates of BIM execution plans or BEPs. However, it's a document that describes who will deliver what, when, in what format, using what software, and deliver it to whom, who will review it, who will approve it, and what's the time frame of that process. That is the BEP in a nutshell. And the BEP, as we know, it comes as a response to the EIR, how to achieve the objectives of the EIR. After that, we have to have some sort of an experience, exposure, accessibility to common data environments, the CDE. After the CDE comes the cherry on top, which is the BIM tools that everyone confuses about. That is BIM, it's the tools, is the tool, is the BIM. There's a lot of confusion about the BIM tools in the market. I've seen a lot of clients that they use a particular authoring software and they consider, yeah, I have achieved BIM. I'm BIM enabled, which is wrong. However, this is the BIM pyramid we adopt in Colabri in our implementation processes with our clients. However, The reason for having this pyramid in our presentation today is to highlight on examples of data that sits in those documents or those requirements. For example, the ISO, it dictates or gives us the actual steps of the process that we need to follow. The EIR gives us the objectives and the approval criteria that comes out from the objectives. BIM execution plans dictates the software solutions, the file formats I need, the time frames. We're going to see later on in the presentation why we need such information. Common data environment, which plays the single source of truth of the project information. And in the BIM tools, we have all the metadata of our BIM objects. For the sake of today's presentation, we picked up one tool that we built in-house internally to enhance our model reviews of our consultants. We get appointed as information managers, and part of that scope is to review models for accuracy. We review model for and to validate the data it have. So the MCR, the model compliance review. In a nutshell, we're going to describe the process or the workflow of the MCR. The MCR, as we all know, it starts with any process within the BIM. It starts with the EIR, the objectives, the requirements, and the BEPs tells us what needs to be done and when. Our consultants, our task teams, the appointed parties, they develop their models based on the requirements in the EIR and BEP. They share it to the CDE, which is, as we all know, it has to be a cloud solution. Then we get to this point. This is a conventional workflow. We've all done it. We are all doing it in our projects at the moment. However, from the CDE, we created an APIs to pull the data from the CDE to another location in the cloud, to run data engineering, to engineer the data that we have. The data is coming from the CDE, it is raw, unprocessed, as is in the native files. So we needed to run data engineering on it. In a bit, we're going to talk what exactly data engineering means. Once we engineer the data, segregate it, analyze it, we get a product or a set of information and data that is clean, ready to be analyzed. Again, through APIs, we push the data, the processed data into a data warehouse where we collect all the cleaned up, cleansed, ready to use data sets, and then we run it into a data analysis software. There's a lot of data softwares that is in the market for running analysis and visualization, and from there we produce the results and reports or dashboards. That process cut down the entire workflow process of reviewing 3D models significantly. The MCR covers the following areas. It checks or inspects the naming conventions of our BIM objects or families. It inspects the data within those objects. It inspects the level of information need, the modeling best practice, and classifications. As I said, adopting that workflow and implementing it, it allowed us to cut around 1,500 working hours of model review process. We all know how manual the process could be. You open the model, review the elements, how much elements you're going to review. It depends on the time you have allowed for the review process. You write down your report. You go back to the CDE, put your status. Well, that process normally would take up to 3, 4, 5 hours, sometimes 1 day, based on the size of the model. With the MCR, no matter how big your model is, the process won't take more than 30 minutes. We can guarantee that. We've run it. For example, this image here, it's taken straight from a report that was issued for a model that has more than 25,000 elements. The review process to get you the score that you need to know what exactly wrong with this model, to accept it, to approve it, what status you should give it, it was done less than 5 minutes. Okay. Now we have the data, we don't know where to start. We're gonna go through major points where we can start to utilize our data, or to lay down the infrastructure and the concrete base to start utilizing the data. We need to have some sort of a standardization for the process, for the classification, the unique class classifications. It has a major role in all BIM models uses. It helps us to aggregate, to differentiate systems and products and solutions within the actual asset that we have. We need to adopt a solution for, or a specification for, the LOD and level of information. You can go for the NBS, or you can utilize the BIM forum LOD specifications, but you need to have one and to be systematic with it. Naming conventions, it's very, very crucial to have your naming convention set up and fixed for your production. After standardization, we go for the architecture. Data architecture means that you need to identify and map the sources of information that you have. Which software gives me what type of data, in what format? Where does it go? How is it being stored? How is it being pulled or pushed? Once you map your entire architecture of data, you can tell what are your requirements in terms of storage, in terms of automation of that data. Does it need to be done on weekly basis, or on daily basis? The architecture is a crucial step to understand your data flow. After we're done with the architecture, an iterative process starts to review the software that we have. What capabilities does it have? Do we need to upgrade it? Do we need to replace it? How can we automate as much as we can from extracting the data? Where is it being processed? What's the end game of that piece of information that I'm acquiring from software X? So you start with your data architecture. After your data architecture, you go to the data engineering phase, where you have identified all of your sources of information. Where is it being stored? Now, if we look back to the previous slide, I think we can't look at the previous slide. Anyway, data engineering means that we need to cleanse our data, the raw one that is coming straight from the software. It comes unstructured, could be, or uncleaned. The data engineering phase means that we need to work on for example, the naming of the fields that we have. Do we need to add extra calculations to get some sort of information that we need that is not generated by the software? Everything I need to do, from aggregation, segregation, analysis, extra calculations, cleansing of the data goes within the data engineering phase. Once I'm done with my data engineered, we can store it in our data warehouse, where the data is ready to be pulled into analysis softwares. From the data warehouse, we need to identify the relationship between those sources of data. Are there any links? Is one parameter plays a role in another parameter in a different data source? We need to link the data together to identify which is affected by which. After we draw all our data relationships, what goes with what, we go to the analysis. That means we have a data now that is ready to be analyzed, ready to be visualized. The data analysis is a combined effort between the data analyst and the business analyst. The business analyst is the guy who knows what sort of information needs to extract from those reports. What decision do I need to support? What information I needed to support that decision, to get an informed business decision? While the data analyst, it provides the actual calculations and visualization of that data. So it's a more of a combined effort, as I said, between those two individuals or two experts. The visualization of data is the fun part in the entire process, where you can go artistic with it to show your skills in visualizing your charts and your graphs. But as an advice, the more appealing the dashboard or the report, the more understandable, the more that people would approach it with openness. A lot of people are scared of data charts. I've been scared of data charts. So the more appealing your visualization, I mean, there are courses being given how to make your data visualization more appealing and more welcomed for the end users. And that would be my presentation. Thank you so much for your time and for your presence. If anyone is interested to know more about data and BIM or the MCR, if you are registered in the BIM Coordinator Summit, you can drop me a note, a message there, and I will get back to you, or you can reach me out on any of those contact means. Meanwhile, again, thank you so much and have a wonderful rest of your day.